In this short video, we're going to explore how we use log-log plots to uncover power law dependence in functions. So let's suppose we have an electric field, and we expect the electric field to depend on the minus 3/2 power of the distance from an object. If we take data for this, it might look something like this. And one of the problems with showing our data in this form is that this data to our eye is indistinguishable from, say, 1 over z dependence, 1 over z squared dependence, exponential in the distance dependence. It's not really clear that this really is z to the minus 3/2. So we're going to use a trick similar to what we did in log linear plots in order to extract the power dependence, the minus 3/2, and get a plot that looks something linear. So what we'll do is we'll take the base 10 log of both sides, and on the right hand side we can simplify that by writing that as log e naught minus log of z to the 3/2. And we can pull that 3/2 out and rearrange so that we get an expression that looks like log of e of z is equal to minus 3/2 log of z plus log of e naught. Well, this is really nice because it shows a linear relationship now between the log of e of z and the log of z. So if we were to just plot log of e versus log of z, we should get something that looks like a straight line. And the slope of the straight line will tell us the power that we expected in our original functional dependence. So in this case, we should expect that the slope would be minus 3/2, telling us that the functional dependence is z to the minus 3/2. We can also extract the constant by finding the y-intercept, and that would tell us the overall constant in our electric field. So if we plot the log of e of z versus the log of z, indeed we get something that looks like a straight line in this case. And we can do a best fit line, and the best fit line shows that indeed our slope is negative 1.45, so close to negative 1.5. As we expected, it should be negative 3/2. And so if there was a unknown dependence on z, we could use this to find that unknown dependence. How do we do this in Excel? What we do is we just create 2 new columns. Our first column will be log of z, and we'll use our built-in function log base 10 to calculate the log of the distance z, and we'll fill that column out. And then we can do the same thing for log of e of z, and do log base 10 of the electric field. And so now we have calculated the log of z and the log of e of z, so we can generate a new plot. And indeed now we see that linear dependence of the log of e of z on the log of z, as we expected. So this is a very useful way of extracting the power law dependence in an unknown relationship.